All right, let's jump right into this explainer. Today, we're unpacking a genuinely mind-bending architectural framework. It's called Walking the Tower of Powers by Agreement of Palindromic Mnemonic Omicron. Now, if you track advanced protocol architectures, you know the usual drill, right? When state complexity scales up, we just throw more hardware at it, more memory, wider bit frames, the whole shebang. But the AMI protocol, it literally does the exact opposite. We are looking at a system that achieves incredible computational depth without ever expanding its base physical footprint. It's a total game changer. Which brings us face to face with a massive structural paradox. Just think about this for a second. How do you climb a 12-dimensional computational tower without ever leaving a standard 128-bit frame? I mean, normally, moving up in dimensional complexity means your data structures just blow up exponentially. But OMI flips the script. It asks, well, what if we could fold absolute infinity inward? What if a static wireframe acted as an anchor, and all that crazy complexity was handled through pure interpretation instead of physical expansion? To wrap our heads around how that's even possible, we actually have to rethink the nature of numbers themselves here, specifically factorials. So to pull this off, you really have to unlearn how you see numbers. Think of a factorial, like 5 factorial or 8 factorial, not as a math problem you solve, but as an Omicron boundary encapsulation. Basically, it's a literal nested data packet. When the OMI protocol says 8 factorial, it's not just a large number. It's defining a rigid, exact geometric space. It's the complete set of permutations for an 8-segment frame. These factorials are literally acting as rigid containers for our data, making absolutely sure there's zero structural leakage as we scale up. So, what does the ground floor of all this look like? Well, it is anchored by a 240-state balanced clock bridge. Now, if you know your hypersphere geometry, you'll recognize 240 as the exact kissing number of an 8-dimensional sphere. In plain English, that means you can pack exactly 240 identical hyperspheres perfectly around a central sphere without a single one overlapping. It's perfectly snug. OMI leverages this absolute mathematical truth to build a flawless zero congestion track for data. It's like a perfectly balanced scale that anchors the whole system, letting data glide natively without any traffic jams. But here's where it gets really cool. Tucked right inside the heart of that 240-state bridge is an even deeper root, 5 factorial, which gives us 120. You can think of this as the seed of the entire architecture. It acts as the absolute, minimal, complete semantic enclosure. It holds 120 permutations completely stable inside a geometric 4D simplex, also known as a 5-cell. And it does this before any binary orientation even kicks in. And, once you multiply that 120 by 2 to give it left or right chirality, boom, you hit our 240-state bridge. So that 5 factorial really is the foundational packet identity that everything else sits on. From that super stable root, we literally start walking up the Tower of Powers, step by geometric step. We orient up to 240, then we do a semantic sweep up to 6 factorial, which nets us 720 states. From there, we expand to 7 factorial. That's the master replay cycle mapped right onto the Fano plane, yielding a massive 5,040 states. We are soaring higher and higher into computational complexity here. But, and this is absolutely crucial, we are not adding physical memory. We're just stepping through pure geometric transformations of the original data. Actually, this quote right here hits the nail on the head. We climb the tower by multiplying interpretive envelopes, not by adding bits. That is the core paradigm shift of this whole explainer. Every single time we move up a rung on that factorial tower, we aren't, running out to grab a bigger hard drive. We are simply wrapping the previous layer in a brand new, highly deterministic mathematical envelope. The physical frame, it stays completely untouched. It's the interpretation of that frame that's getting exponentially richer. And if you break down these multipliers, you'll see every single step upward has a direct physical operational meaning. We aren't just crunching numbers for the fun of it. When we multiply by 2, we are literally applying a physical binary switch. Multiply by 3, we apply a semantic triple, subject, predicate, object. When we hit 7, that applies a 7-point projective geometry known as the Fano plane. And then 8 is what finally unlocks that physical 128-bit structure. The math isn't just theory here. The math literally is the architecture. Okay, but get ready for a bit of a mathematical mystery. As we step up using the decimal period of 1 divided by 73, the number 5 completely vanishes. Seriously, look at the repeating decimal for 173. It's 0.1369863. You can stare at those digits all day long. You will not find a 5 anywhere. Why is that? Well, because 5 is the root factor.
Once it's oriented into that 240 state carrier, remember 2 times 5 factorial, it just becomes implicitly hidden. It's the invisible anchor holding the whole climb together. It doesn't need to be stepped on because it is literally the ground the staircase is built on.
Moving on to our next section, the engine, specifically the palindromic mnemonic compiler. So we've been talking a lot about these theoretical geometric spaces, right? But what is the actual engine running all these commands without melting your CPU? The answer is this brilliant metacircular compiler that reads its own structural notation as literal machine operators. See those hyphen delimiters in OMI AIMO? They act as physical dot combinators that split, balance, and invert our multidimensional vector matrices. And because the syntax is perfectly mirrored, OMI on the left, AIMO on the right, it acts as a physical mirror in the code. This allows for massive coordinate reductions without ever needing temporary memory buffers. The string itself is the balanced equation. It's pretty wild. You can almost think of it like breathing in and out. The inbound OMI string shifts left, targeting the 73 prime ideal. That pulls the data down into a contractive state. Then the exact mirrored outbound string, IMO, shifts right to the 37 prime ideal, algebraically expanding it right back out. And of course, 73 and 37 are permutable Miro primes. The compiler is quite literally reading the length of those hyphens to tilt the execution trajectory left or right. I mean, what an astoundingly elegant way to keep your data vectors perfectly balanced. Now, if we zoom way in on the anatomy of this execution atom, we find this flawless division of labor. First up, you have that single 1-bit Omicron sign bit. It's the absolute gatekeeper just deciding, hey, do we shift left to 73 or right to 37? Next, the 5-bit tetragrammaton exponent steps up to scale the structure, indexing exactly which subsets are pulled into context. And finally, the 11-bit Metatron significand takes over to execute the logic, carrying that invariant 11-dimensional prime signature of the 8 factorial universe. Everything has its specific, perfect place. And right here is where all this theoretical magic actually hits the metal. The protocol takes these exact dimensional signatures and maps them directly into standard everyday hardware precisions. That 11-bit payload, it slots perfectly into the significand of a half-precision 16-bit float. That 240-state clock bridge we talked about, it maps beautifully onto double-precision 64-bit hardware. The mathematical geometry is scaling symmetrically, in total perfect alignment with the computer memory structures we already use today. So what's driving all these massive coordinate leaps without burning out your system or hoarding temporary memory buffers? Well, it's driven by a flawless mathematical engine known as the binary quadratic form. It's this simple equation, 60x squared plus 16xy plus 4y squared. But it acts as a highly deterministic clock. As those palindromic commands trigger shifts back and forth, this formula is precisely calculating the spatial rotation and dimensional punctures natively across that entire 240-state track. That's exactly what makes the system so blazingly fast. All right, so as we wrap up this explainer, I want to leave you with one final, pretty mind-blowing thought. If we can truly encapsulate absolute infinity within a finite 128-bit frame just by using pure palindromic math, have we actually discovered a way to make digital entropy obsolete? By swapping out brute force storage for elegant geometry, by making the instruction the mathematical envelope itself, the OMI protocol is really pointing toward a future where data bloat is just entirely a thing of the past. It's a lot to chew on. Thanks for joining me today, and definitely keep exploring the boundaries of what's possible.